Okay, I decided to take another quick little video too with the butane so that we can compare it to one of the problems we did in the other videos, just to like really figure out how to look at a Newman projection with the fourth priority group facing toward us, and how to then interpret which configuration we're going to have, whether it will be an R configuration going clockwise or whether it will be an S configuration going counterclockwise. So before we do that, let's just first look at the butane. Automatically from this perspective, you can see that these molecules are all three that are connected to the carbon that aren't connected to the center one are facing away from the carbon over here. So these are all facing that way, and these are all facing this way. And that happens naturally because of the electron cloud density. They are most stable and most comfortable, obviously, in this configuration, in like a staggered and facing away from each other. So knowing that no matter which way you turn it, every atom connected to that chiral center, that carbon, is going to be facing away from the entire projection. You know now that if you're looking at a Newman projection head on, like this, you know that all the ones in the front are going to be facing you, and all the ones in the back are going to be facing away from you. And so now, with that knowledge, you can now tackle a Newman projection. So we're going to look at the Newman projection from the front, the first one that's facing us, which is this one. And then we're going to take a look at it really quickly just to see our priority groups. So I already gave them priorities because it's the same ones from the problem I did in the other video. And this is first priority because of the oxygen. This is second priority because it was connected to a carbon connected to a nitrogen, whereas this one's connected to a carbon connected to a hydrogen. So this one was our second priority. Our third priority was the methyl group, and then our last priority is the hydrogen, which it usually is. And they're all assigned priority numbers based off their atomic number. And so sometimes there isn't a hydrogen there, right? And sometimes the methyl group is number 4 because there's something else in the spot. And so it all comes back down to atomic number. And so yeah, so we have 1, 2, 3. And at first glance, it looks like it's going counterclockwise, which is an S. And we know that isn't the case, right? Because when we did it, it was an R. But how can we prove that to ourselves? Now, like, assume that we don't know what it is, and so far it looks like an S. You can go ahead and you can say, well, I know because this is the front projection, it's facing towards me, hydrogen is facing towards me, and that can't be right? Because our fourth priority should be the one that's facing away from us. So we can assume, hey, okay, so counterclockwise isn't right, that means clockwise is correct, and then that's it. Or you can take it a step further and try to visualize it from a person perspective by drawing a little person behind this Newman projection, looking at it from the back, and drawing what they see and seeing what they see. Or I'm just going to go ahead and show you why it is clockwise or an R configuration. So let's go ahead and assume now this is our center carbon, right? Our top one here is going to be the top one there, which was the oxygen, and that was our first priority. We're going to kind of just label them as we see them. And then I'm going to place this 2 here in the center, even though we know it's this carbon back here. But I'm just going to place it here because that's easier to see in the Newman projection, just like we see it there. Our 3 was the methyl group on the bottom right. Okay, and then our 4 was the hydrogen. And now we can see, look at that. Hydrogen's facing towards us, 3 is facing towards us, 1 is facing towards us, and 2 is actually facing towards the back or away from us. But we want to shift that, right? We want the 4 facing away from us. And so what we're going to do is we're going to turn it until this thing right here, the hydrogen that's holding that 4 priority group, is facing all the way away from us. And let's keep our numbers in the same exact spots. We're just going to move them so we can see them a little bit better. So we know our 4 is back there. We know this is still our 1. We know this is still our 2, which is, now that we can see that other carbon, we can assign it correctly. and we know this is still our 3. Or if you were more comfortable just leaving on the center because that just made you confused, that's okay too. But we know that it's our center because it's the carbon behind it. And so now, with the 4 all the way in the back, like it's supposed to be, if we look at it again, it's 1, 2, 3 clockwise, which is an R configuration. And that's why when you're looking at it head on like this, it's a little bit hard to see. And he says maybe turn your paper this way and try to look at it like that. But that's kind of hard to see because, again, these are all 2D images, right? They're all 2D drawings, and it's hard to kind of see that in 3D. And for me, it helps to see someone from behind there looking at it and drawing what they see. Or you come into class with this already set up. I don't think you would be allowed to have these numbers. But honestly, even if we didn't have these numbers and you practice it all day long, every day up until the exam, you'd be able to just remember that this was our 1, or just reference this. Reference what you have drawn on your paper. Top one was number 1, the middle one was number 2, and the bottom to the right is 3. 1, 2, 3, clockwise. So yeah, this is an R configuration. I just wanted you to see it. And the other one that we did in the problem was the back one. It was facing away from us, so that means if the hydrogen was on any one of these, it's already facing away from us, so we were safe at drawing it in the perspective that we saw it in. Okay, I hope that helped.